Nature has endowed the earth with glorious wonders and vast resources that man may use for his own ends. Regardless of our tastes or our way of living, there are none that present more variations to tax our imagination than the soil, and certainly none so important to our ancestors, to ourselves, and to our children. The mission of the Dr. Charles E. Kellogg Soil Survey Laboratory is to measure soil properties that are critical to soil survey and conservation efforts of the USDA Natural Resources Conservation Service and the National Cooperative Soil Survey. Data for these properties contribute to decisions concerning best use and management of soils. Located in Lincoln, Nebraska, the Kellogg Laboratory employs numerous full-time technicians and scientists who analyze thousands of samples annually. No other facility in the world carries out as wide a range of soil analytical methods. Laboratory information serves as the basis for maps showing distribution, limitations, and best use of soils. Soil data and maps are freely available to the public online. The life cycle of a laboratory soil sample begins in the field, where soil scientists describe and collect samples. Reasons for collecting samples include natural resource inventory, mapping, classification, and interpretation of soils, and research projects. The work of the Kellogg Laboratory is carried out in several sections, including sample receiving and processing, chemical analysis, mineralogical analysis, physical analysis, biological analysis, and spectroscopic analysis. Each sample that arrives at the Kellogg Laboratory is assigned a unique number, establishing an electronic audit trail, documenting the handling and analysis of the sample throughout the various sections of the laboratory. Soil samples are first air-dried and then processed by hand. The less than 2 millimeter fraction is called the fine earth fraction. This is the reactive portion of the soil and is the fraction that is analyzed by the laboratory. After soils are processed, they are stored in this room for analysis. These larger containers have quality control samples. An appropriate quality control sample is analyzed with every batch of test samples. If results for a quality control sample are outside established limits, corrective action is taken. After all analysis have been completed, there is a multi-level review process to ensure the quality of the data. In the chemical analysis section, soils are tested for pH, available phosphorus, total carbon, trace metal content, and other chemical properties. Here an analyst is determining cation exchange capacity, which is a measure of the ability of the soil to hold plant nutrients. The Kellogg Laboratory continually seeks ways to improve methods using new technology and also develops new methods based on the progressive needs of soil science. The laboratory uses the latest technology to maintain a cutting edge in data quality and analytical efficiency. In the soil mineralogy section, soil minerals are identified and quantified. Much of the reactivity of a soil is due to certain minerals, which influence soil characteristics, such as availability of plant nutrients, the capacity of the soil to hold water, and the rate water moves through the soil. Soil mineralogy also influences engineering interpretations, such as shrink-swell potential and suitability for use as construction material. Sand and silt mineralogy is evaluated using a petrographic microscope. Clay minerals are too small to be seen with an optical microscope, so they are identified using an X-ray diffractometer. Thermogravimetric analysis is used to quantify certain minerals by evaluating thermal properties as they are heated to high temperatures. In the physical analysis section, soil properties such as particle size distribution, bulk density, and water retention are determined. Here, particle size distribution is being evaluated to determine soil texture. Texture drives many interpretations and has a significant influence on the capacity of the soil to retain nutrients and water, the rate of water movement, and bulk density. Bulk density influences the penetration and growth of roots, movement of water and air, and the suitability of the soil for various uses. Water retention data are used to estimate plant available water, which is a key factor for predicting native vegetation and the suitability of different soils for agricultural use. There is growing interest in biological properties related to soil quality. Because land management has a significant impact on soil quality, soil samples representing different types of land management may be analyzed for indicators of biological activity, such as soil organic carbon and enzyme activity. Soil carbon in the form of organic matter is an important sink in the global carbon cycle and also influences soil structure, tilth, aggregate stability, and water retention. Soil spectroscopy is an efficient alternative to conventional laboratory methods for the estimation of soil properties. Statistical models are developed from spectra of soil samples that were also analyzed by conventional methods. These predictive models are used to estimate soil properties of unknown samples from their spectra. Research on quantitative soil spectroscopy is continuing and has the potential to improve the efficiency of a range of chemical and physical analysis. Soil scientists use laboratory data to classify and interpret soils for landowners and other stakeholders. Civil engineers use soil survey data when planning the construction of a highway. Laboratory data are used to assess and validate soil conservation practices recommended to farmers to minimize erosion and improve soil and water quality on working lands. Other federal agencies use soil data to assess important ecosystems, such as wetlands. This reflects just a small portion of our customer base. At the NRCS, we understand the need for soil analytical data, and the goal of the Kellogg Laboratory is to help ensure that those needs are met. The Kellogg Laboratory curates the largest soil archive in the world, with hundreds of thousands of soil samples from all 50 states and over 70 foreign countries. These samples represent decades of soil inventory, as well as use of soils data for conservation efforts concerning one of our nation's most valuable and least understood natural resources. Here, for example, is a soil sample from the Houston Black Series. It was collected from Bell County, Texas in 1980. Because these samples are stored in an air-dried condition, little change in their properties is expected. These historical samples and reference data are invaluable for the efficient investigation and application of new analytical methods. On behalf of the National Soil Survey Center, we want to thank you for your interest in the Dr. Charles E. Kellogg Soil Survey Laboratory. If you would like additional information about the Kellogg Laboratory and its mission to support soil survey and soil conservation efforts, please visit us online at soils.usda.gov.